Welcome to the new part of AI application series. In this part, we will be discovering different AI application development tools. There are several emerging open source no code or low code AI application development platforms. One of those is flowise, and it is built on top of LangChain and provides a no code, low code approach towards building AI, RAG application, agents, and many other type of applications that we will be discussing in a moment. We have a look at its competitors. We have like Revit that you can install on your machine, and it also provides a designing surface or design surface that allow us to create AI workflows and helping us out building AI applications without writing any code. Another one in this category is DiFi, and they have cloud offering as well, just like all others. Cloud offerings are generally expensive and limited, but as these are open source, we can always pull containers or directly install them on our local machine. There is a GitHub link here. And this platform is an open source LLM development platform, orchestrate LLM apps from agents to complex AI workflows. And with the RAG engine, we can see they have a design surface as well. And we will be pulling in some containers or we will be directly installing them on our machines. Let's get started. Let's install Flowise on our local machine using Docker's Hub. And let me pull the latest tag. It will take a while. Now let's use Docker Compose to create the container from the image. If you are new to Docker and Docker Compose, listing the running container. Here we have the Flowise container running on port 3000. We are running Flowise AI on localhost port 3000, and I can log into it. Alternate approach is to download Flowise from GitHub repository, and we can pull a specific tag. I created a folder, my web apps, and inside that I'm running git command. I'm trying to clone a particular version of Flowise. Here is the tag. I assume that you have already installed Git on your machine and you can follow along. So we have Flowise here. So I'm running pnpm install here. It will take a while. Now run npm run build. Now once the build finishes, we can run npm run start. Flowise server is now running on localhost 3000 and let's try it out. It is localhost and 3000 here. And here we have the flowise and develop different types of applications with flowise. I'll be discussing few of them like customer support automation or chatbots for your website or for any type of customer support. Then we can develop retrieval augmented generation AI applications that can help us to chat with our documents and extract or summarize the information we need. Then we have AI agent development, where we can develop a workflow that can take decision and can execute any tool to get the output. Then we have data analysis that includes financial, healthcare, environment, or any other data that we like to analyze using no-code flowise. Then we have language translation, where we can convert one language text into another language. And here we are talking about a natural language, human languages like Korean, Japanese, Chinese, English. Now we have question answer systems and then AI workflow automation. So these are few of those use cases where we can use Flowise. One important thing about the Flowise is that it is built on top of LangChain, which is a Python library, and it helps us to create AI workflows. Let's have a quick look at Flowise documentation. It has getting started section here, and it is also showing that how we can install Flowise. And here we have some information about different components. This documentation is useful if you want to develop different types of applications using Flowise. And there is a video tutorial here, and it is really good. Get detailed information about different types of applications we can develop using components or no code components. Before we build a simple RAG application using Flowise, let's walk through the user interface. Here we have chat flows that help us creating or adding new chat flows. Then we have agent flows. It will help us creating AI agents. Then we have assistants to build AI assistants. Then we have a marketplace that we can use for quick start templates, add hub, spot contact, API agent, create Airtable record, and there are number of others. We can make a copy of these templates and change them to serve our purpose. Move on to the tools. We can add different tools here that can be integrated or connected with AI agents to perform tasks on behalf of user. We have the credential section here where we can store the credentials of other services we like to use with our assistants, agents, or chat flows. Environment variables. And then we have API keys here. We have API keys here that will help us consuming web APIs, and then document store here. And this section allow us to upload documents that we can later use with RAG flows. So let's get started with our first workflow. I'm adding a new workflow. So I'm saving it here. RAG Qdrant app. Now when I click plus here, I can see different subcomponents, and you can observe that it's LangChain, Llama index, and it's there are utilities here. So for LangChain, I have different sections available here for different types of components that I like to drag and drop onto my design surface here. And that includes agents, some of pre-built agents like Airtable agent, AutoGPT, and similarly many others like CSV agent, OpenAI assistant, a number of them, XML agent. Then I have cache here, cache component, in-memory cache, Redis cache. I have different chains here, question answer chain, conversation chain, large language model chain, and I can pick any of them based on my requirement. Chat models. So In case you want to use Azure or AWS chat model, you can find them here. And in my case, I'll be using a model that is downloaded in LM Studio on my own machine. So I'll be using local chat or chat local AI. Otherwise, you can also use online chat services or large language models from different vendors. Then we have document loaders. They help us to actually build RAG systems like GRI Web Scraper. It will allow us to provide URLs and websites will be scraped and data will be vectorized and stored for further querying. We can provide CSV files and docx files, and there are a number of other integrations available here, even GitHub and Gitbook, Notion folder, PDF files, and you can observe there is S3 buckets. We can upload all of our documents in AWS S3 bucket and then we chat with those documents. This is something that will allow us to convert all of our uh, documents into vectors and then store them in some vector store or in memory, and then we can provide them to a large language model. So there are different offerings available here. I'll be using local AI embedding. Otherwise, you can use online services to generate your embeddings. We have briefly discussed embeddings concept in our vector DB video. We have prompts here. We have memory section here. This memory section will allow our chatbot or our application to remember previous conversation history. It will take in account the previous conversation to respond to the newer queries. We have moderation here, record manager, retriever, text splitters. Retrievers will help us to retrieve our data, vector store retriever, for example, of text splitters available here that will help us to actually split the data embedding model before we can feed them to create vector form of the text. Tools available for chat. We can also add custom tools. Our agents can use all of those tools available here along with the custom ones. Then we have vector store here. We can use different types of vector stores. Most of the popular ones are available here like Astra, Chroma, Couchbase, Document Store. Then we have Elasticsearch, Files, in-memory vector store, and Milvus, MongoDB, Pinecone, Postgres, Qdrant, and Redis, and many others. Let's get started with in LM Studio. Let's start the models. I have downloaded few models here. Let me start the smaller one here like Llama 3.2. I'm also selecting Nomic Embed Text and turn it on. I can access my models at this particular URL. Let's build our first test application here. Test app and selecting few components here. In chains, let me pick up LLM chain. And I need a language model and a prompt. For models, let me pick one of the chat models here. And I will pick chat local AI. And for this minimal application, I also need a prompt. So I'm picking this prompt template here. Set a few values here. And here we have the base path. based on LM Studio. Here I can provide anything. I can provide anything as I am running model locally. So it can be anything. In model name, I can paste the same identifier from LM Studio. In prompt, I can type you are a sport ant. I can connect this prompt and model with LM chain, save it. Let's try it out here. Hello, my name is Burhan. So it is acting like an ant here. Let's change it a bit and suggest 10 names of pet, and pet is our variable here, and here I can select this pet question, save it, and now let's try it out. Let me clear the prompt. Horse. So it's giving me 10 names for the horse. Let's change it a bit here and let me add JSON structured output parser here just to test out if the things are working properly. And you can find a lot of such videos on Flowise website as well. Connecting it and changing the prompt as well. Here we have few changes in the prompt template. I have added extract name, age, and gender of the student from the context to return a JSON output, and I've given the context in curly brackets information, and in format prompt values I have appropriate key value here. Then if you go to structured output parser, here I have added age, gender, and name with appropriate types and description. And in the structured output parser, I've added properties, age, name, gender, and with appropriate type, string and numbers. And then we have description here. The description will be used by our LLM to create the JSON. And it is important to provide a description that can help. Let's try it out. And here we have the JSON output. Let's start building RAG application. I'm pulling a conversational retrieval QA chain here. A chat model, adding a chat local AI, adding a vector database, adding embedding, local AI embedding here. In this case, I'll be using web scraper. I can either use PDF or a web scraper to load document that I can vectorize later on using local AI embedding and then store in Qdrant. And I need a text splitter here as well. I'm ready to build a complete RAG application now. These are the minimal components, though we can add couple of more like record manager and memory. But for simplicity, I will continue with these six components on my design surface. First, I have a character text splitter that will allow me to split text in chunks, small segments of text that can be vectorized and stored. Now, we need to specify a URL here, and I'll use this Wikipedia article on Milky Way. Connecting the local embeddings. I will use localhost 1234 and embedding model name. Now make embed text version 1. Here I have the same base path, model name here, and I will connect vector database to vector store retriever in the chain and chat local AI model with chat model. Qdrant vector database server is running locally on port number 6333, and I have test 6 here, and I need version 1 here, and save again. For this rag, I'm just using one URL, but I can add multiple URL. Now I like to vectorize all the text I scrap from web scraper and split it and then save into the Qdrant using the local AI embeddings. For that purpose, I will use the upsert option here. I have changed this splitter to recursive character text splitter for better results and with a chunk size 2000 and chunk overlap 300 for my Milky Way URL. Upserting. Now let's try it out. Let me see if it gives me the correct answer here. It is also giving the reference, which is the same URL.